Today, actually, my own main purpose is to focus on how the variation of different type of birds raised as single or mixed in a pen. For the protein diets, that's just for the convenience of see the difference. So main focus about the variation of the different system. So my presentation will go through background a bit and about experimental design. I will show you the data of the study and we'll have some conclusion. So just some background about the research settings, how you use birds with the different sexes. So as you all know that feather sexing is not possible anymore for the broilers. For both companies, Averaging and Corp Ventures, we couldn't get feather sexing birds from the hatchery now. So what we do, at the moment, most people are using the male birds from parental lines, either that's the father or the off-sex birds. Some people also use the as hatched birds, but whether these two options are good or not, we haven't done much research on it actually. So for the sexing itself, what we can do if we cannot do feather sexing, certainly probably all of you know that there's a van sexing option. But for this one, we need experienced sexer to do it. As shown in here, you can see it, but it's hard for a lay person to do it. Another way is do the DNA sexing, which you can get up here just a feather and extract DNA from the feather to run PCR. In here, we set up a SC called high resolution melting curve analysis, which is pretty simple and can be large scale. So you can tell the difference between male and female through the melting curve. And this paper is nearly published in Poultry Science. So then we use single or mixed sex birds for research. That's the question. So in terms of the uniformity or variation, we need to have good between pen variation because we want to use limited replicates to get enough power to separate the difference between treatments. And now, for the same-sex birds, certainly that's what we've been using for long, but now it's a challenge because we cannot use proper broilers, male-only birds anymore. So another way is that you can mix the female-male at equal number of birds in a pen, in all the pens. So that can give you good in-between pen uniformity or variation. For as hatched birds, if that's randomly distributed in the pens, because they are not equal male or female in the pens, that can have big variation. But just remember, if you're doing research at the end of the trial, you can actually sex birds by opening up. So you can know the birds, know the sex of the birds in the pens at the end of the trial. Well, that's the three different scenarios. We can see here that's the male-only birds. That's what we've been using. And now you're using the printed lines from the hatchery, which is still sexable, but not for the broilers. And then you can vent sex the birds on the arrival of the birds on in the facility. So you can actually allocate the birds equally into pens to make it even. That can give you good variation or the uniformity. And of course, the option is about you just distribute birds randomly without knowing the sex of the birds. So that's pretty random. You can have, you know, more female or less female in a pen. Excuse me. So the hypothesis we had was that the experiments with equal number of males and females in the pens should have similar between pen variation as single sex birds. That's what we try to hypothesize. And also the use of sex as covariate in the analysis may reduce the variation, so we can improve the experiment power if you just use mixed birds with randomly distributed into pens. Here is the experiment we did. So we had basically 2 levels of protein with 3 different racing systems, meaning that in a pen we mix birds with same number, same numbers of male and females, and raise birds in a pen just female and another just male. So that's 3 different systems. And we used Copperfield 500 and then 3 phases. For these 3 phases, we measured the pen weight, feed intake, and then calculated FCR with 14 birds per pen and 8 replicates. So on the arrival of the birds at uni, we request a sexer came over, and the birds were then sexed. So we can have the opportunity to mix birds equally or put male female only in the pens. At day 34, we also measure the individual body weight of the birds so that we can have a chance to look at the individual response from the birds by protein level and the racing system, and we can look at male or female birds response. With that individual body weight, we can actually do a simulation as what we put birds randomly in mixed pens, in the pens with mixed sex birds. So we just separate protein levels, so we don't mix up with protein levels, but for male, female, we just put them randomly into a dummy pen. So that's the diet we used. Just look at the protein level, about 2% lower for reduced protein, and the normal protein, that's according to the requirement of the chickens. Excuse me. So that's the data we have produced. So for the pen weight, that's the average of the pen we measured. I just show you the day 35 day weight gain, FCR, and feed intake. So in here, we did factorial analysis, and we've seen that only weight gain had significant interaction between gender or sex and the protein level. So in here, we can show that for the standard protein feed, the chickens, male, female, and mixed birds, the body weight or weight gain, just, you know, in male, that's higher than mixed, and then female. So mixed is basically in the middle, and it's pretty much like a linear relationship between them, you know. But for reduced protein, the response is slightly different. So for the reduced protein, male is also highest, but the mixed birds and the female birds didn't have significant difference. And the level of reduce of the weight gain is also slightly, you know, you can see the slope. It's not as big as the standard protein level. So for the feed intake and FCR, you can see that male birds and mixed birds and female birds, so feed intake is reduced according to male mix and female mix is in the middle, and for FCI it's increased. The same response, so there's no interaction here. So for the CV of the performance, you can see here the mixed birds is pretty much the same as, or sometimes lower as the male female. So it's pretty equivalent. And now, if we look at the individual birds at day 34, so the female birds and male birds, they have the body weight is different, and also the protein level, the reduced protein level has lower body weight at day 34 for individual birds as well. So in here, we only looked at the sex by diet interaction because it's significant. And in terms of the analysis, so because the racing, I just didn't mention, racing didn't have the significant effect. We can mix the male, female at different protein level independently. And then we can look at the coefficient of variation at day 34. So we can see if we put sex percentage as covariate, this is we call ANCOVA. The variation is significantly different. We had a dummy run of 10 simulations, so we can do statistical analysis. And it's pretty much equivalent to the half-half male-female. So it's looking good. So take-home message, we can see from this trial, the female birds respond to low protein diet differently from male birds. Seems not as much as male birds. And maybe the requirement of the protein level for female birds is different from male, of course, but the breed spec may be more reliant on male birds rather than female birds. And also equal mixed male and female birds in a pen has similar variation as single bird sex birds. So the last probably is more useful. By the use of sex as covariate in analysis, we can use randomly distributed birds in pens. So you don't have to sex at the start of the trial, but you can open up later on so that you have the number of birds as number of male-female birds you can use as covariate. So that's the team. I acknowledge everyone contributed to the project, especially Kos and Ashley. They too did the trial and analysis as well. We actually just finished a trial recently. And also for the animal facility at uni, they did a fantastic job on setting up the facility. And of course, AgriFutures for the funding of the project. And everyone in the project group at uni, without them, the sampling and all those activities wouldn't be possible. Thank you, everyone.